It's deep in the past, and you're on the African plains under a brutal sun, looking down at your own bare, dark skin. Almost everyone thinks the mystery of skin color is why some skin is dark. That's backwards. Dark skin is where we all started. It's the original human setting, the baseline our entire species shares. For almost all of human history, everybody alive looked more or less like this. The real question is why any human skin ever turned pale at all. What could possibly make a body give up that deep, protective shade? The answer turns out to be a quiet, desperate fight between a specific vitamin and your ability to have healthy children. And the trail ends somewhere shockingly recent, far more recent than people tend to guess. Once upon a time, our ancestors were covered head to toe in thick fur, the way apes still are today. But then we lost it. We traded that heavy coat for bare, sweating skin, probably so we could run down dinner on the baking savanna without overheating. The moment the fur went away, bare skin under the African sun had to go dark to survive. Here is the thing about losing that fur. It wasn't just about cooling off. It was a hunting weapon. Out on the baking plains, our ancestors could jog after dinner for hours. Hairless and sweating, they stayed cool, but the animal they chased couldn't sweat. It just ran and ran under the hot sun until its body overheated and dropped. They traded the fur coat for the power to outlast anything on four legs. And that change was ancient. Dark, bare skin was locked in more than 1,000,000 years ago. So for almost all of human history, everybody was dark-skinned. Everybody you would have met walking across the earth, for thousands upon thousands of generations, was dark-skinned. Pale is the new thing that needs explaining, not the other way around. The danger near the equator isn't really sunburn. That's what we think of first, the redness and the peeling, but that's just the surface of the problem. Sunlight quietly destroys a nutrient in the blood called folate. It silently breaks it down as the light passes through the skin and into the blood just beneath it, draining away something the body badly needs. In an experiment, strong simulated sunlight wiped out 30 to 50% of the folate in human blood in about an hour. That was in a lab dish, but it points to a real problem out in the world. Blood runs close to the surface of the skin, so under a strong sun, that same folate is exactly what sits in harm's way. Losing it, quietly and invisibly, is the real threat of the tropics. Folate is what a body needs to build a healthy baby, to grow a healthy fetus. It's the raw material for new life, the scaffolding for a child's developing spine and brain. Lose your folate to the sun, and you lose healthy children. Without it, pregnancies fail, and the lineage simply stops right there in the dirt. So what's folate, really? It's the stuff a body uses to build brand new cells from scratch. Every time a body needs to make tissue, heal a cut, or grow, it reaches for folate. And here's the thing. A growing baby in the womb is basically a big construction project. It burns through a huge amount of this stuff to build a spine and a brain. When the sun drains that folate, it's stealing the bricks meant for the next generation. So dark skin is sunscreen with a purpose. Melanin is a shield that guards your folate and therefore your babies. This is the explanation for equatorial skin championed by researchers Nina Jablonski and George Chaplin. The pigment isn't there to make you look one way or another. It's there to keep the sun from stealing your future. But if dark skin is so protective, why did anyone ever lose it? Because there's an opposite need pulling the other way. The skin makes vitamin D out of sunlight, using the ultraviolet that gets through. A body needs this vitamin to pull calcium into the bones and keep the immune system running right. It's just as vital as folate, just for a different reason. Near the equator, there's so much sun that even dark skin makes plenty of vitamin D. The shield lets just enough light through to keep the body running, while still blocking the brunt of the damage. But walk north, away from the equator, and the sun gets weak, low, and seasonal. The sky is gray for months on end, and the light that does reach you comes in at a shallow angle. Now dark skin becomes a problem. It blocks too much of the little ultraviolet there is, and the body can't make enough vitamin D. Without vitamin D, you get weak, sick bones, especially in children. A dark shield in a dim land means your bones bend, Your body aches, and you struggle to survive the long, dark winter. Picture the northern winter. You go months with nothing but thin, gray light. The sun hangs low and tired on the horizon, offering almost no real warmth. When a child grows up in that dim light, their body just can't make enough vitamin D. Without it, calcium doesn't get pulled into the bones the way it should. The bones stay soft. They bend. Legs bow inward. It's a quiet, painful struggle just to stand up straight in the snow. So far from the equator, the pressure flips. You have to dial the melanin down to let the weak sun in. This is the best explanation we've got. Skin color is a tug-of-war between two things you can't live without: protect your folate or make your vitamin D. It's a constant balancing act between keeping the bad stuff out and letting the good stuff in. Near the equator, folate wins and skin stays dark. Far away, vitamin D wins and skin goes pale. Skin color tracks the sun, almost like a dial turned up or down by latitude. It's not a random accident or a deep, mysterious choice. It's pure geography, written right into the surface of your body by the angle of the Earth. And the change can be shockingly small. Much of the difference rides on a single gene called SLC24A5. The light version differs by basically one letter of DNA, one swapped building block out of billions. It's almost nothing, a typo in a massive genetic book. But that tiny typo completely changes how much pigment a body produces. Scientists found it by accident in a pale, golden-colored zebrafish. They were studying these little fish for completely different reasons, noticed one was lighter, and tracked it back to that one tiny swap. Flip that one letter, and skin lightens a lot. It goes to show how a massive, visible difference across whole populations can come down to a microscopic change in the code. Almost every person of European descent carries the pale version of that gene. It spread wildly across that continent over time, becoming the new normal for millions of people. Almost nobody in Africa or East Asia does. They carry the older, original version. One tiny genetic switch, flipped in some places and not others, splitting the map right down the middle. Here is where it gets strange. Pale European skin is astonishingly recent. Scientists read the DNA of a hunter-gatherer who lived in what's now Spain about 7,000 years ago. He still carried the dark-skin version of the genes. He was a European, living and hunting in Europe, but his skin was still the original deep shade of his ancestors. And, weirdly, he already had blue eyes. Dark skin and blue eyes 7,000 years ago, right in the middle of Europe. That combination doesn't match what most people picture when they think of the deep past. It proves that these traits didn't all change at once in some great package deal. The eyes shifted first, and the skin took a very long time to follow. The pale skin we picture as European only swept across the continent in roughly the last 8,000 years. Some of it arrived with early farmers moving in from the Near East, bringing their own agriculture and their own genes with them. These farmers replaced or mixed with the dark-skinned hunters, and their lighter skin became the new standard across the land. In evolutionary time, that's basically yesterday. It's not some ancient, deep-rooted thing that stretches back to the dawn of mankind. It's a recent, local adjustment. The shift to farming meant people were eating less meat and less vitamin D, which may have pushed their skin to lighten even more to pull what it could from the weak northern sun. Diet and latitude likely pushed in the same direction. Just let that sink in for a second. For almost the entire human story, every single person walking the earth was dark-skinned. The pale skin some people have now showed up only a heartbeat ago in the grand timeline. We're talking about a tiny, recent blip at the very end of a massive history. Sit with how strange and recent that really is. The way a lot of people look today is brand new. And here's the part that catches people off guard. East Asians also have light skin, but they didn't get it from the same genes as Europeans. Evolution ran into the same weak northern sun problem twice, in two different places, and solved it two different ways, with different mutations. The same knob turned down twice by two separate sets of people independently. Here's the thing. There are two separate groups of people, oceans apart, never meeting, never trading notes. Both of them are handed the exact same weak sun problem, and both of them quietly turn the same dial down, using different inner machinery to get there. The sun wrote the same answer twice. It's the same test, given to different students in different rooms, and they both ended up with the exact same grade. Separate lineages finding the same practical answer to the same cold problem. The European switch and the East Asian switch are not connected by blood or migration. They're connected by the sun. When the environment hands you the exact same puzzle, evolution will often reach for the exact same solution, even if it uses totally different gears to get there. So put the whole thing together. 1,000,000 years dark, then, just recently, and in a few places, pale. Skin color isn't some deep, fixed core of who a person is. It's a thin, recent, local setting, tuned by no more than how much sun fell where your ancestors happened to live. The most visible thing about a person is one of the shallowest and newest. It's just a snapshot of where your ancestors stood under the sky and what they were eating while they stood there. It's a dial set by the weather, not a badge of identity. The bodies that walked out of Africa were built for the sun, and the bodies that walked into the snow slowly, quietly bent to fit the cold. You look at your own skin today without giving it a thought, but it's just the latest page in a very long story about light and shadow. So here's the thing I keep coming back to. If you were dropped on a sun-baked plain or a frozen northern coast, do you think your own body would have changed to match? Be honest. Let me know down in the comments.